Definition: Philippe Kruchten, Grady Booch, Bittner, and Rich Reitman derived and refined a definition of architecture based on work by Mary Shaw and David Garlan Shaw and Garlan 1996. Their definition is: software architecture encompasses the set of significant decisions about the organization of a software system, including the selection of the structural elements and their interfaces by which the system is composed, behavior as specified in collaboration among those elements, composition of these structural and behavioral elements into larger subsystems, and an architectural style that guides this organization. Software architecture also involves functionality, usability, resilience, performance, or use, comprehensibility, economic and technology constraints, trade-offs and aesthetic concerns. In Patterns of Enterprise Application Architecture, Martin Fowler outlines some common recurrent themes when explaining architecture. He identifies these themes as the highest level breakdown of a system into its parts, the decisions that are hard to change, there are multiple architectures in a system, what is architecturally significant can change over a system's lifetime, and, in the end, architecture boils down to whatever the important stuff. Island software application architecture is the process of defining and coming up with a solution that is well structured and meets all of the technical and operational requirements. The architecture should be able to take into account and improve upon the common quality attributes such as performance, security, and manageability. The main focus of the software architecture is how the major elements and components within an application are used by, or interact with, other major elements and components within the application. The selection of data structures and algorithms or the implementation details of individual components are design concerns. They are not an architectural concerns, but sometimes design and architecture concerns overlap. Before starting the architecting of any software, there are some basic questions that we should strive to get answers for. They are as follows: how the users of the system will be interacting with the system? How will the application be deployed into production and managed? What are the various non-functional requirements for the application, such as security, performance, concurrency, internationalization, and configuration? How can the application be designed to be flexible and maintainable over time? What are the architectural trends that might impact your application now or after it has been deployed? Goals of software architecture: building the bridge between business requirements and technical requirements is the main goal of any software architecture. The goal of architecture is to identify the requirements that affect the basic structure of the application. Good architecture reduces the business risks associated with building a technical solution, while a good design is flexible enough to be able to handle the changes that will occur over time in hardware and software technology, as well as in user scenarios and requirements. An architect must consider the overall effect of design decisions, the inherent trade-offs between quality attributes such as performance and security, and the trade-offs required to address user, system, and business requirements. Principles of software architecture: the basic assumption of any architecture should be the belief that the design will evolve over time and that one cannot know everything one needs to know up front. The design will generally need to evolve during the implementation stages of the application as one learns more, and as one tests the design against real-world requirements. Keeping the above statement in mind, let's try to list down some of the architectural principles. The system should be built to change instead of building to last. Model the architecture to analyze and reduce risk. Use models and visualizations as a communication and collaboration tool. The key engineering decisions should be identified and acted upon up front. Architects should consider using an incremental and iterative approach to refining their architecture. Start with baseline architecture to get the big picture right, and then evolve candidate architectures as one iteratively test and improve one's architecture. Do not try to get it all right the first time. Design just as much as you can in order to start testing the design against requirements and assumptions. Iteratively add details to the design over multiple passes to make sure that you get the big decisions right first, and then focus on the details. A common pitfall is to dive into the details too quickly and get the big decisions wrong by making incorrect assumptions, or by failing to evaluate your architecture effectively. When testing your architecture, consider the following question: what were the main assumptions that were made while architecting the system? What are the requirements, both explicit and implicit, this architecture is satisfying? What are the key risks with this architectural approach? What countermeasures are in place to mitigate key risks? In what ways is this architecture an improvement over the baseline or the last candidate architecture? Design principles. When getting started with software design, one should keep in mind the proven principles and the principles that adheres to minimizes costs and maintenance requirements, and promotes usability and extensibility. The key principles of any software design are: separation of concerns. The key factor to be kept in mind is minimization of interaction points between independent feature sets to achieve high cohesion and low coupling. Single responsibility principle. Each component or module should be independent in itself and responsible for only a specific feature or functionality. Principle of least knowledge. A component or object should not know about internal details of other components or objects. Don't repeat yourself. The intent or implementation of any feature or functionality should be done at only one place. It should never be repeated in some other component or module. Minimize upfront design. This principle is also sometimes known as YAGNI. You ain't gonna need it. Design only what is necessary. Especially for agile development, one can avoid big design upfront BDUF. If the application requirements are unclear, or if there is a possibility of the design evolving over time, one should avoid making a large design effort prematurely. Design practices. Keep design patterns consistent within each layer. Do not duplicate functionality within an application. Prefer composition to inheritance. If possible, use composition over inheritance when reusing functionality because inheritance increases the dependency between parent and child classes, thereby limiting the reuse of child classes. This also reduces the inheritance hierarchies, which can become very difficult to deal with. Establish a coding style and naming convention for development. Maintain system quality using automated QA techniques during development. Use unit testing and other automated quality analysis techniques, such as dependency analysis and static code analysis, during development. Not only development, also consider the operation of your application. Determine what metrics and operational data are required by the IT infrastructure to ensure the efficient deployment and operation of your application. Application layers. While architecting and designing the system, one needs to carefully consider the various layers into which the application will be divided. There are some key considerations that need to be kept in mind while doing that. Separate the areas of concern. Break your application into distinct features that overlap in functionality as little as possible. The main benefit of this approach is that a feature or functionality can be optimized independently of other features or functionality. Be explicit about how layers communicate with each other. Abstractions should be used to implement loose coupling between layers. Do not mix different types of components in the same logical layer. For example, the UI layer should not contain business processing components, but instead should contain components used to handle user input and process user requests. Keep the data format consistent within a layer or component. Components, modules, and functions. Key considerations. In the previous section we talked about key considerations that need to be kept in mind while architecting or designing an application. We also touched base on what needs to be kept in mind when we are dividing our application into various layers. In this section let's take a look at some key considerations for designing component, modules and functions. A component or an object should not rely on internal details of other components or objects. Never overload the functionality of a component. For example, the UI processing component should not contain data access code or attempt to provide additional functionality. Explicitly state how the components will communicate with each other. This requires an understanding of the deployment scenarios your application must support. You must determine if all components will run within the same definition. Philippe Kruchten, Grady Booch, Bittner, and Rich Reitman derived and refined a definition of architecture based on work by Mary Shaw and David Garlan, Shaw and Garlan 1996. Their definition is: software architecture encompasses the set of significant decisions about the organization of a software system, including the selection of the structural